So what happens when you heat solid substances? So we know that solids are fixed to its position, correct? They vibrate. Now when I supply heat energy to this one, okay, what do you think is going to happen to this? They vibrate faster. When they vibrate faster, the kinetic energy is higher, I agree. What happens? The distance? So what happens to this? They expand. Have you seen this kind of thing somewhere, like where they have taken into account that things will expand, so they have correct, exactly. So the railway tracks, actually you could see there is a wires. What happens is during summer they expand and during winter they contract. So there is always a small gap that they have left, because during expansion it should have that space. Otherwise what do you think is going to happen? It will bend. It will be dangerous actually, because it's in the railway track and you want it will be like this, and how will the train go? So they actually calculated and they have actually left some space. When you supply heat energy, what happens? The same thing happens. This one gains energy and they start moving faster. The spaces in between these molecules will be greater, so they expand. The volume increases. The liquid also same thing. So they move faster, the volume increases. Solids more visible because you can actually feel it and see it. Okay. Now the heat always transfers from the hotter region to the colder region. So now I think you would have seen this experiment. We have a rod which will have some wax on it. So if I heat at one hand, what do you think is going to happen? So if I, let's say like I am going to take a rod like this and I have wax here and I heat this at this end, which one will fall first? This one or that one? This one. Okay, fine. So everyone knows that if I actually heat up here, what happens is first this part is heated up and it will move here. So this one actually falls. But what do you think is going to happen if I also heat here? Okay, so you say this and this will fall at the same time. Heat supply, let's use a similar candle. Okay, so assume that it is almost same. Then we can say that this and this falls at the same time. Okay, so now the heat is coming from this direction. Here the heat is moving in this direction. What do you think will be at the center? Will it be very hot or will it be very cold? Okay, we know that here it will be very hot, correct? Here it will be very hot, here also it will be hot, and it is actually traveling like this, and this is also traveling like this. After a few minutes, after like let's say like 5 or 10 minutes, then all these things have dropped, correct? Here also it's all dropped, and when you come here, this also then drops. But after that, this heat is, because by this time it has actually traveled to this point, and here also it has traveled to this point. Now at the center, what do you think? Will it be more hotter than this one? Equal to what? Equal to this?
These two ends.
Equal to these two ends? I am going to now do this experiment. Okay. I am heating both the ends at the same time. This one came first. See, actually now, right now I am not feeling hot. Why? The center. Because it's just yes, it's not yet transferred to the center. So till that point I am safe. Don't worry. So the second one here fell. So which one is falling now? Third one? Okay, but when you are trying at home, be careful, okay? You're not going to try it out? The second one also. So at the ends it's very clear, like it's really hot. correct? So now at the center I am able to hold it. I am able to hold it. It's not that hot. Here also it's not hot. Here also it's not hot. Here also it's not hot. No, I am not feeling. Here it's hot. Okay, so heat is traveling this direction. It's not like when you supply heat, it actually travels quickly so that everything is hot. I am able to hold this part. Okay.